friends, welcome to Skill on Tech. Today we will see various methods of hydrogen production. As we all know, with the increase in global population and rising economic growth, demand of fuel energy is also increasing. This increase in fuel demands can be met by using hydrogen gas as the fuel. Hydrogen is a chemical element with the symbol H and atomic number 1. Hydrogen is the lightest element on the earth so far. At standard conditions, hydrogen is a gas of diatomic molecules having the formula H2. It is colorless, odorless, tasteless, non-toxic and highly combustible gas. The non-toxic nature and high combustibility leads the hydrogen to be used as a fuel. So let us see various methods for the production of hydrogen. First method to produce hydrogen is using the fossil resources. Main fossil resources are natural gas, oil and coal. They provide low-cost, large-scale hydrogen production with SMR, which is steam methane reforming, and CCUS, which is carbon capture utilization and storage technique. So natural gas can be converted to hydrogen using SMR technique, whereas coal gasification is done to produce hydrogen using CCUS technique. Next method for the production of hydrogen is using biomass and waste. They utilized biogas reforming and fermentation of waste stream from ADG, which is anaerobic digester gas, and it is a combination of methane and carbon dioxide. So both biomass and waste is converted to hydrogen and thus energy. Next method for the production of hydrogen is using electrolysis. They provide gateway to small to large scale hydrogen production options. It includes mainly three approaches. First is splitting of water in direct sunlight. Second is high temperature electrolysis, whereas last one is low temperature electrolysis. Fossil fuels gave the major contribution for the production of hydrogen. Natural gas and oil contributes to approximately 48% and 30% of industrial hydrogen production. Natural gas, which mainly includes methane, reacts with water to produce hydrogen and carbon dioxide. As we can see, this is a two-step process in which methane reacts with water to produce carbon monoxide with hydrogen, and carbon monoxide is further reacted with water to produce carbon dioxide and hydrogen. Hydrogen can be produced using oil by partial oxidation. As we can see from this reaction that the partial oxidation of oil produces hydrogen and carbon monoxide. Coal gasification contributes to 18% of global hydrogen production and produces syngas from coal, water and air. As we can see here, carbon monoxide is produced in first step, which is further reacted with water to produce carbon dioxide and hydrogen. Here in all the three methods, which includes use of fossil fuels for the production of hydrogen, results in increasing carbon emission, affecting all living beings on the planet. So we can go for the third method, which is electrolysis. Electrolysis is a promising option in future for carbon-free hydrogen production from renewable and nuclear resources. It is the process of using electricity to split water into hydrogen and oxygen. This reaction takes place in a unit called an electrolyzer. Electrolyzers can range in size from small appliance size equipment that is well suited for small scale distributed hydrogen production to large scale central production facility that could be tied directly to renewable or other non-greenhouse gas emitting forms of electricity production. So let us see how electrolyzers work. They mainly consist of a positively charged anode and a negatively charged cathode separated by an electrolyte. Different electrolyzers function in different ways, mainly due to different type of electrolyte material involved and the ionic species it conducts. Most common type of electrolyzers are PEM, which is polymer electrolyte membrane, alkaline electrolyzers, and solid oxide electrolyzers. So let us see how polymer electrolyte membrane electrolyzer work. In a polymer electrolyte membrane electrolyzer, the electrolyte is a solid, especially plastic material. This is the cheapest method of electrolyzing. In this, water reacts at a positively charged anode to form oxygen and positively charged hydrogen ion, which are called protons. The electron flow through an external circuit and the hydrogen ions selectively move across the PEM to cathode. At the cathode, hydrogen ions combine with electron from external circuit to form hydrogen gas. All these steps can be seen in these chemical equation. Here the first step takes place at anode, in which water is splitted into the hydrogen ion and oxygen. In the second step, which takes place on cathode, these hydrogen ions combines with electron to form hydrogen molecule. Next type of electrolyzers are alkaline electrolyzers. Alkaline electrolyzers operate via transport of hydroxide ions through the electrolyte from the cathode to anode, with hydrogen being generated on the cathode side. Electrolyzers using a liquid alkaline solution of a sodium or potassium hydroxide as the electrolyte have been commercially available for many years. Newer approaches using solid alkaline exchange membrane AEM as the electrolyte are showing promising result on the lab scale. What type of electrolyzers are solid oxide electrolyzers? They used a solid ceramic material as the electrolyte that selectively conducts negatively charged oxygen ion at the elevated temperatures, generate hydrogen in a slightly different way. Steam at the cathode combines with electrons from the external circuit to form hydrogen gas and negatively charged oxygen ion. The oxygen ions pass through solid ceramic membrane and reacts at anode to form oxygen gas and generate electrons for the external circuit. If you like this video, hit like button below, share it with your friends and colleagues, subscribe our channel for getting updates on upcoming videos. Please leave any comments or feedback to improve the videos. Thank you.